Hey, this is Mr. Aiden. We're in our second video of Unit 8, that's Applications of Integration. We're going to be taking a look at motion with integration. Again, we've taken a look at motion with derivatives, but now we're going to be taking a look at motion with integrals. And if you've had me since 9th grade physics, or if you've taken a look at my videos since 9th grade physics, you know this really well. Is when we have displacement, or x of t, we might use s of t, we might use d of t. Displacement, we're just going to use x of t. In order to find the velocity of that function, we're going to be taking the derivative. D of x over d of t is equal to the velocity as a function of time. And so we're going to take the derivative, or the slope of the line, right? The slope of the line. Well, if we have velocity and we want to find acceleration, if we want to find acceleration as a function of time, we're going to be taking a look at dv over dt, the derivative of the velocity with respect to time. Or we can take the second derivative of the position with respect to time, and we're going to take the slope again. And so if we want to go forward, we're always going to take the slopes, or the derivatives. Well, guess what? If we want to go the opposite way, we want to take the integral. If I want to find the velocity as a function of time, then I'm going to find the integral of the acceleration as a function of time with respect to time from a to b, from two values there. If I want to find the position as a function of time, I'm going to take the integral of the velocity as a function of time. I'm going to take the area, okay, from 2 points, from A to B, the definite area. So we're going to take the area, or we're going to take the integral going backwards. And so that is the antiderivative, is our integral. And so we can use this for motion as we take a look at each point in time. Now keep in mind that displacement, velocity, and acceleration are what we call vector quantities, which means they have magnitude and direction. Keep in mind the scalar quantities would be something like distance, which distance, if we want to find the distance of a function, we would be taking the integral of the absolute value of the velocity with respect to time. What's the scalar quantity of velocity? Well, that's speed. So how would I find the speed of a function? I would take the integral of the absolute value of acceleration with respect to time. And so if we want to take a look at the velocity, which is a vector quantity, we're going to be taking the integral of acceleration. If we want to take a look at the speed, the scalar quantity, which is just magnitude, just how far, what's our speed, is the integral of the absolute value. So let me give you some examples. So here we're going to take a look at the displacement. And let's say we're taking a look from 0 to 10. Okay, the displacement from 0 to 10. We're taking a look at the area, which that is a positive area. That is positive displacement. And here we have a negative area, or negative displacement. Okay, and so if we're trying to take a look at displacement of this full area, I am going to find out my integral from 0 to 10 of 5 minus t dt. And that would find out my displacement. Now, of course, here we could also use, in something very easy, we do 1/2 base times height. So 1/2 of the base times height. So we have 5 times 5 is 25, 25 divided by 2. So that is the displacement I've gone. Here, I've gone negative 25 over 2, which means the total displacement would be 0 meters in this case, if we're dealing with meters. If we're dealing with feet, it's feet, but here we'll take a look at meters. Now keep in mind, if we're going to take a look at the distance of my function would be the integral from 0 to 10 of the absolute value of 5 minus t dt, which that would be 25 over 2 and 25 over 2, which what would 25 over 2 plus 25 over 2 be? That would obviously be 25 meters. Okay, I've gone a total distance of 25 meters. Remember, distance is scalar, which means scalar does not matter about direction at all. I've gone positive 25 over 2. I've gone 25 over 2, which is 25 meters. If I were taking a look at the average displacement, Let's take a look at the average displacement. I would do 1 minus 10 minus 0 of 0 to 10 of 5 minus t dt. And so that was from the last video of finding the average. And keep in mind, because of the mean value theorem, we know there's some point at which it will equal this average right here. One last thing is, let's say we want to find the what the position is. And let's say at t equals 0, we start at a position of negative 5 meters. Well, we started at, if we want to find the position, we start at negative 5 plus the integral from 0 to 10 of 5 minus t dt, and that would give me where my position is. So my position is kind of my displacement plus my initial position plus x naught right there. Okay? So that was a long drawn out way of finding my displacement. Okay, now here we're going to try to find my distance. That's what I said before. How do we find distance? Well, distance is the absolute value of that function from 0 to 10. Okay, let's take a look at, let's move into some other examples. Here it says a particle moves in a straight line with a velocity. Here's my velocity function. I graphed it out. That's negative t squared plus 8 meters per second. Time is in seconds. At t equals 2, the particle's distance is 5 meters. So that is my initial position. At 2, we're at a position of 5. And we want to find the total distance. So if I want to find total distance, I have a couple different ways to do it. The easiest way to find total distance is we're going from 2 to 6. Those are my limits of integration. Distance, we're going to do the absolute value of the velocity function with respect to time. And you do have in your calculator an absolute value function. There's a little button in order to find the absolute value function. And that would give you the total distance. There's another way to do it, is you could also solve for negative x squared plus 8 is equal to 0 and solve for that x right there in your calculator, which that would end up giving you 2 root 2. That's where your root is. And we could find out my integral from 2 to this guy. So the integral from 2 to 2 root 2 of my velocity function with respect to time. Then we could find out the area over here, which would be, and I'm going to kind of erase this if that's okay, so I can write on my little graph right here, is from 2 root 2 all the way to 6 of v of t dt. And then you're going to make all of this positive, aren't you? Because who cares about the negative? I know I'm going to get a negative area because my area is negative here. My area is positive over here. You add it all up, and that's my distance, isn't it? That's my distance. And so I didn't have to do anything with this initial position because I wasn't looking at position. All I'm looking at distance. This is the easiest way to do it, is what's the absolute value from 2 to 6 of this function, okay? And put that in your calculator. Let's take a look at another one. We have another function right here. We're trying to find the particle's displacement from 1 to 6. So what would the displacement be? Well, again, there's more than one way to skin a cat. There's 4 ways to skin a cat. The easiest way to skin a cat, in this case, to find out the displacement is equal to, we do the integral from 1 to 6 of v of t dt. And that would give you your values. Okay. Another way to do it, obviously, is you could take the integral from 1 to 4, of v of t dt. You take the area from 4 to 6 of v of t dt, and you add those both up. And you're going to get a positive area and a negative area. You add those up, and that is the displacement. If you want to find the distance, you wouldn't care that this was negative. You would make this an absolute value. You would add these up, and that would be the distance. But this is in order to find the displacement. Okay. Here, and again, I'm bringing you through each of these problems. This one is asking you for the particle's position at 7 seconds. Well, In order to find out the position at 7 seconds, we have to know what's the position at 2 seconds. At 2 seconds, it's 8 meters. So whatever you're going to get for a displacement is going to be added on to this 8 meters. So now we're going to take the integral from 2 to 7 of this square root of 3t minus 1 with respect to time. And so if you want to find the position, we're going to start with this initial position plus the displacement, and that would give you where our particle is. Okay, remember, if we were to try to find out the average from 2 to 7, we would do 1 over 7 minus 2 from 2 to 7 of this square root of 3t minus 1 dt, and that would give you your average. So we took a look in this video of how do we find average, how do we find displacement, how do we find distance, how do we find the actual position, all different ways. Displacement, we're taking the integral of v of t dt. The distance, we're taking the absolute value of v of t dt. The actual position, we're adding that displacement to whatever my constant is wherever I began at. So that's motion with integration. See you guys.